Hello and welcome to R&D Mathematics. Today we are going to talk about graphs of functions. Actually, graphs of base functions. So the first one is linear function. Linear function means any function of this form, fx equal mx plus p. Now this this is the slope. When we learn about linear equation, we learn these things. And this is the y-intercept. Actually, this is y-coordinate of y-intercept. So y-coordinate of y-intercept. Now, shape, you already know. If m is positive, it will look like this, and if m is negative, it will look like this. Of course, this place, for example, this is a positive height, so your b is positive in this case. And see, let's see some examples. F of x equals 2x minus 7. So the slope is positive, you have this kind of shape, and minus 7, because of that, it intersects your y-axis at negative 7, or something like this, somewhere here, right? Now the base function of this type is f of x equal x. So y equal x, you know how to draw that. Y equal x, so f of x equal x. It goes like this, 45-degree angle, because slope is 1, because this guy is actually 1x plus 0, right? So y-intercept is 0 and slope is 1. That's our base function. Now, even any linear function, let me go to the previous page. Any linear function, it can be this, or it can be this shape. If you observe it, any linear function, any linear, okay, domain is all real numbers. You can input any real numbers, because see, domain is when you project your graph down to x-axis. That's your domain. And here you have to project upward, also in this case like this and like this. So the shadow of your graph upon x-axis, see, it's all x-axis. That's why domain is all real numbers. And if you think about it, range also everything, all real numbers, because again, if you think about the shadow onto y-axis, because it's a line, it's infinitely dimension line, infinitely length line, it will cover everything. So linear functions, that's pretty easy. Okay, next, square function. Before that, actually, this one, let me put constant function. This actually, it's also linear. F of x equals b. So for example, f of x equal, let's see some example, f of x equal 5. So the function value 1, 2, 3, 4, 5. So it's a line going through 5, actually 0, 5, that point, because this guy is actually 0x. Now the slope is 0, and you know when the slope is 0, the line is horizontal, plus 5, right? So no matter which values for this function, f of 8, still 5, f of 1000, still 5, right? That's what this graph means. See, f of 8, that value is 5, f of 1000, no matter how far you go, it's a horizontal line. That's a constant function, but it actually belongs to linear function, a special case. Next, actually, you know what? How about this? this special linear function, let me go to my previous, see, linear function, if I make this distinction, okay, now our lines here are not horizontal. Now this is valid. That's why I did it, because except for constant functions, this is true for all linear functions. Because now if I ask you what is domain and range of this function over here, what would you tell me? Domain, no problem. The shadow, well, it's everything, negative infinity to infinity. How about the range? Pause the video and think about it. So if you shadow it, if you take the projection onto y-axis, what will happen? Assuming you thought, let me use red color. If you shadow it, because this is a line, you are going to get only 1 point. So your range is actually just 5, just one number. Okay, that's a point to note. And next we are going to talk about square functions. Now later, using these functions, we will draw general graphs, but today only base functions. So square functions. Square functions. Now, base function is this type. Now what we are going to do, the easy way, let me give you some x values. F of x. So f of x is negative 2 squared. We need parentheses, so we get 4, and negative 1 squared we get 1, 0 squared which is 0, 1 squared which is 1, and 2 squared which is 4. Now we quickly, you don't have to do this again and again. Once we learn our base functions, we can use them again and again. So negative 2 comma 4 somewhere here, negative 1 comma 2 somewhere here, 1 comma 2 somewhere here, 2 comma 4 somewhere here, 0 comma 0. So it looks like this, and we call it a parabola. It's not two lines, there's a curve in shape, so we call it a parabola. Now any function, let's say g of x, any square function like 3x squared plus 7x minus 8, this is a square function or quadratic function. Any square function will have either this shape or this shape. So what will basically happen is we can do transformations. That's maybe in our next video. So this, you start with your base function here, and then you shift it either right, left, up or down, and then you stretch it or you shrink it, whatever. Using that transformation, it will always remain either this shape or this shape. And it's worth to note here, let's say g of x equal negative x squared. That base function is this, because it will just flip because of this negative sign. We will be talking about these things in detail. Next function, cubic function. So you have to remember these shapes. First, we are showing you why this is true using these tables. Now let's think about cubic function. So the base function is f of x equal x cubed. So f of x equal x cubed. Here x versus x cubed. Let's take let's take the same set of values that we took earlier. Negative 2 to the cubed, so you get negative 8. Here negative 1 cubed, negative 1, 0 cubed which is 0, 1 cube 1, 2 cube 8, right? So negative 2 comma negative 8 this time, so somewhere down here. And then negative 1 comma negative 1, so this point. And 0 comma 0, it goes through the origin, 1 comma 1, and somewhere here, 2 comma 8, finally somewhere here. So it has this nice shape. It's like this. This is the shape of cube function. And I forgot one thing, so let me go back. In square functions, I forgot to tell you domain and range. So what is the domain? Domain, you project it down to the x-axis. So it goes like this, right? It keeps going. So you will get all x-axis. But how about range? You have to be careful here. Range, if you project it, now let me use blue color, towards y-axis, what you are going to get is only this part of y-axis including 0. So 0 to infinity. Which makes sense because our square function, if for example, if somebody asks you for any for any value, for any x value, can it be negative numbers, negative 5? No, right? Never, because x square is positive. So it's, now you have to remember carefully, this is only for the base function. Depending on your function, again, this domain will still remains the same, but the range will, this number will vary. For example, you know what, let me show you. For example, here in this case, the range of g is not 0 to infinity, but see, 0 to negative infinity. Well, not 0 to negative infinity, negative infinity to 0. Normally we put the large number in the right hand side, so negative infinity to 0. And for example, if you had something like this, and let's say this point is negative 1, in that case, okay, you cover everything upward, so the range of that guy is negative 1 to infinity, right? Or if you had something like this, and if this point is 1, then range is negative infinity up to all the way up to 1, right? Okay, that's the idea. And next, okay, we learned about, well, cubic function. Domain of cubic function is actually everything, negative infinity to infinity, and range also everything, because it goes from negative infinity to infinity. It's everything. Next one, square root function. So square root function. Here, the base function f of x equal square root of x. Oh, this is m as x raised to 1/2. Now, to learn this one, let me choose some values x, f of x. So we are talking about f of x equal, square root of x. So I will choose some numbers, 0, 1, without, well, 2, because if I choose 2, square root of 2, it's not a nice number. So, you know, just to get the shape, 4, 9, 16. So I'm taking all those square numbers. So square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, this is 4. So 0, 0, 1, 1, 4, 2, so 1, 2, 3, 4 somewhere here, 1, 2 somewhere here. See, it's not, well, it's increasing, but it's slowly increasing. And then 9, 3 somewhere here, 14. So it has a shape like this. This is the shape that you have to remember. Now, I have a question for you. Think about this. Why did I choose 0? Why didn't I, let me show you. Previous, I choose negative numbers. See, in all previous things, I choose negative numbers. But here, in square root function, I only choose positive numbers. Why didn't I choose negatives? Because square root of negative numbers, it does not exist, right? So in this case, your graph is not continuing to the left side of your x-axis. It looks like this, and the domain of this function, okay, pause the video and think. Yes, you are correct. 0 to infinity including 0. And the range of f, again, 0 to infinity. Because when you project this guy down towards y-axis, still it will cover this part of your y-axis. And if you project it towards x-axis, you will cover again only the positive part of x-axis. So this is this and this is this, which makes sense, right? And next thing, can you guess? Yes, cubic root function. So the base function f of x, cubic root of x, we put it like this, or this is m as x raised to 1/3. Now, again, some table. So x versus cubic root of x, which is our, cubic root of x. This and write it again clearly. So f of x is cubic root of x. Now let me choose these values, -8, -1, 0, 1, 8. Because I'm choosing these values, -8, 1/3 is -2. -1 to 1/3 is -1. Because when you cube this guy, you get -8. 0 is 0, 1, 2. Now, if you draw this, -8, 2. So 1, 2, 3, you go far away in x-axis, but little bit in y-axis. So -8, 2 like this. -1, 1 somewhere here. Then 1, 0, 0, 1, 1, 1, 8. So it will have a nice shape. Well, it's kind of, it reminds us the cube function, only it's rotated and flipped. Let me see. Cubic function, it was increasing faster, but cubic root function, see, the other way around, not exactly, it's rotated and flipped. Okay, that's the cubic root function. Well, again, domain and range. Actually, domain and range both are -infinity to infinity of all real numbers. That's another way of writing it. All real numbers, remember guys, that's this. Okay, next we are going to learn absolute value function. So the base function f of x, absolute value of x. Now again, this is really easy. So x and absolute value of x, let's choose simple numbers, 1, 2. Absolute value of -2, 2, 1, 0, 1, 2. So if you draw -2, 2 here, -1, 1 here, 0, 0 here, 1, 1 here, 2, 2 here. See, it's two line segments. Remember, this is not x squared. It looks like it's a parabola. Here, it's sharp point here, sharp vertex here. It's two lines, which makes perfectly sense because if you remember, the definition of absolute value is, remember that we learned this, x and negative x. X is when x is positive, negative x is when x is negative. Now this part is exactly this piece of our, see, that's this, because f of x equal x, it looks like this, and f of x equal -x graph is actually this part. So it's a piecewise function, and remember that v shape absolute value function looks like this, and it nicely match with our definition, mathematical definition. Now, the domain of absolute value function, -infinity to infinity, because when you project it down, it covers the whole x-axis, but the range exactly like in our case of a square function, 0 to infinity. Okay, the last function we are going to learn, reciprocal function. Now, this is a little tricky. Reciprocal function. So these are the base functions that you are learning today, and using them you will be in future you will be able to learn, you will be able to draw a lot of different functions. Now in this case, let's draw a table x and 1 over x. Now let me choose some numbers. This table going to be a little bit lengthier. How about this? Negative, well, if x is negative 10, what is 1 over x? 1 over negative 10, right? Or negative 1 over 10. So let's draw that point. So 10, negative 10 is somewhere here. Negative 1 over 10 is negative 0.1. So very close to this one. So, and here over here somewhere, let me write some numbers over here. 1. If x is 1, 1 over 1, which is 1. If x is 2, 1 over 2. If x is 3, 1 over 3. And if x is, 100, 1 over 100. Now let's investigate what's going on here. 1 comma 1, somewhere here. And 2 comma 1 half. So 2 is somewhere here, 1 half. 3 comma 1 third. 100 comma 1. See what's happening here is it's becoming smaller and smaller. It's becoming smaller and smaller like this. And then what about my x value, between 0 and what about if I choose 1 half for x? Then 1 over 1 half, that means 2. See here, then 1 half comma 2. So I will get a shape like this. Because right over here, look at this 1 over x. When x is smaller, x small, f of x is really large because of this reciprocal thing. And when x is large, for example, like when x is 1000, f of x is 1 over 1000, it gets small. Because of this, I have this shape. And same with the negative numbers, so I will get this shape. So, but we have one exception here. Well, I can put negative 1 here, negative 1 right in the middle. Do I put 0? That's the question. Well, the answer is no, because you cannot divide by 0. So x has to be non-zero. So this function, guys, consists of two pieces. Even though it's one function, it consists of two pieces. And this point right here, we omit it. We do not have 0 in our domain. So the domain of this function is what? Everything except 0. Or we write it negative infinity up to 0, union 0 to infinity. And what do you think about the range? Well, range, what you need to do, you need to project it to y-axis. Well, you will get all the numbers, everything except, think about it very carefully. This one is getting smaller, 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 but will it ever be 0? No, it keeps getting closer and closer and closer and closer to 0. So everything except 0 again. So the domain and range is the same. So negative infinity to 0, union 0 to infinity. Okay, guys, that's it for today's video. So you learned many base functions. First linear functions, then constant function. So linear functions, and then constant function, that's a part of linear function. Then square functions, cubic function, square root function, cubic root function, absolute value function, and reciprocal function. And quickly recalling, y equal x looks like this, constant function looks like this, so linear function, constant function, and square function it look like this, base function, cube function it look like this, square root function only the positive part like this, cubic root function kind of like cube function but switched and rotated, and absolute value function look like square function but two lines, reciprocal function finally like this without crossing any axis. It only remains in second quadrant and fourth quadrant. Okay guys, that's enough for today's video. Thank you.